Hello and welcome to Zishan classes. Today we have another question which involves a pulley, fixed pulley and two masses M2 and M1. We have a rope here or a thread. It is said that the thread starts slipping on the fixed pulley when the ratio M2 divided by M1 is equal to eta naught. In that case, we have to find the coefficient of friction between the thread and the pulley. So, to be able to solve this question, we should know that when we draw the free body diagram of these two masses, we should know that the tension acting on these two bodies is different. Also, the reason is there is friction between pulley and the thread. So, we should know that this ratio is the ratio T2 by T1 is given by e to the power of mu theta, where T2 is tension in the tight part and T1 is the tension in the slack part. Now, what is a tight part and a slack part? It's very simple. Since M2 by M1 is equal to eta naught, this implies that M2 is greater than M1. If M2 is greater than M1, this pulley system, you will observe that M2 is going down. If it goes, M2 is going to go down and M1 is going to go up. The one commanding the motion here is M2. So the side of the rope to which M2 is attached, that side is going to be known as the tight part, the tight side, and the one which is being pulled, the part of the rope which is being pulled is going to be known as the slack part. The rope covers an angle of 180 degree from this end to this end. The theta here is equal to pi. If the rope had covered this much, the theta in this case would be equal to pi by 2. So, this was the concept that is required in this case, and obviously mu is the coefficient of friction between the rope and the pulley. Now, if we draw the free body diagram of the masses M2 and M1, we see that there are two forces acting on each of them. Also, the condition here is that the thread starts slipping. At that point of time, the motions of these two bodies has not started. It's about to start. In that case, acceleration of both the masses is equal to 0. But if these two bodies move, this one is going to go down and this one is going to go up. That is why I've mentioned that the acceleration now is equal to 0 but is directed downwards and upwards for both of them, like that. Also, if we want to write the equations for these two bodies, since the acceleration is 0, it's pretty simple that for m2, t2 must be equal to m2g, and for m1, t1 must be equal to m1g. Also, we know from our concept that t2 divided by t1 is equal to e to the power mu pi. This gives us t2, which is equal to m2g, divided by t1, which is equal to m1g, is equal to e to the power mu pi. This implies that m2 by m1 is equal to e to the power mu pi. But we already know from the start of the problem that m2 by m1 at the time the thread starts to slip is equal to eta naught. So we have eta naught equal to this much. Now, this gives us take a natural log on both the sides and we arrive at mu is equal to 1 by pi ln eta naught. So the coefficient of friction which was required has come out to be equal to 1 by pi ln eta naught. Also, we've got one important expression here. We will keep this and this. We've come to the answer of the first part of the question. So we will write these two parts here. Now comes the second part of the problem. The second part of the problem says if the ratio m2 by m1 is eta, which is greater than eta naught, what is the acceleration of the masses? Okay, obviously in the case the ratio becomes larger than eta naught, the ratio m2 by m1 becomes larger than eta naught, these two bodies will develop an acceleration. In that case, the acceleration direction we already know, the direction of acceleration we already know, and both of them are going to have the same acceleration a. In that case, we will write the equations for these two bodies. For m2, the equation is going to look like m2g minus t2 is equal to m2a. For m1, t1 minus m1g is equal to m1a. We know that t2 by t1 is equal to mu pi and e to the power mu pi is equal to eta naught. This gives us t2 is equal to eta naught times t1. We will put t2 is equal to t2 is equal to eta naught times t1 in equation 1. We get m2g minus eta naught times t1 is equal to m2a. from the equation 2, we can write that T1 is equal to M1A plus M1G. M2G minus eta naught times from here M1A plus M1G equals M2A. This gives us M2G minus eta naught M1A plus minus eta naught M1G is equal to M2A. We'll take the terms with A on one side and we will arrive at we know that M2 by M1 in the second case was equal to eta. So we have replaced M2 by M1 with eta and we arrive at the acceleration in the second case is equal to g times eta minus eta naught divided by eta plus eta naught. So these two are the answers for the two parts of the question. That's it. The concept that we have used is the concept of friction between rope and pulley, and the tension, the ratio of tension in the tight part to the slack part is equal to e to the power of mu theta, where theta is the angle covered by the rope on the pulley. So this is it. I'll see you in the next video.